Imagine being present at the birth of the universe, witnessing the Big Bang firsthand. Now, let's dive into the fascinating world of the Big Bang Theory. It is the leading explanation about how the universe began, offering us a glimpse into the very dawn of time. It's like the ultimate history lesson, taking us back nearly 14 billion years to the very cusp of existence. The Big Bang Theory suggests the universe was once an incredibly compact, dense and hot entity. Picture this: all the matter in the cosmos, everything we know, see and cannot even comprehend, was once packed into a tiny, infinitesimally small point. This was not just any point, but a singularity of extreme heat and density. From this unimaginable singularity, the universe began to expand. It was not an explosion in the traditional sense, but rather an expansion of space itself. Everything we know, from the galaxies farthest from us to the air we breathe, started spreading out from that initial point. This expansion is not something that happened once and then stopped. It's still going on. The universe has been expanding ever since that initial moment, like a loaf of raisin bread rising in the oven. The dough represents space, and as it expands, the raisins or galaxies move farther apart. This expansion has been happening for about 14 billion years, and it's still happening right now. As you're hearing this, the universe is getting bigger. The Big Bang Theory is more than just a theory. It is a key part of our understanding of the universe and our place in it. It's a story of origins, of beginnings, and of the vast cosmic drama that is still unfolding all around us. Now, imagine if we could create our own universe, complete with its own Big Bang. The possibility may seem far-fetched, but hold on to your curiosity as we explore this idea in the next scenes. Stay with us on this journey to the edge of scientific understanding and beyond. Creating a universe may sound impossible, but with the right understanding of physics, it might just be within our grasp. To create a universe, we first need to understand the fundamental building blocks of our own universe. These are energy, matter, space, and time. Energy and matter are two sides of the same coin, thanks to Einstein's famous equation E equals mc squared. This equation tells us that energy can be converted into matter and vice versa. In the context of creating a universe, this suggests an intriguing possibility. If we could harness vast amounts of energy, theoretically, we could convert it into the matter needed to form stars, planets, and galaxies. Next, we have space and time. These are the stage upon which all the matter and energy in our universe dance. They are intertwined in what physicists call the fabric of space-time. This fabric can be warped and stretched by the presence of matter and energy, leading to the phenomena of gravity. So, if we were to create a universe, we would need to create a new space-time. This is where things become extremely tricky. As far as our current understanding of physics goes, we don't yet know how to create space-time. But let's say, for the sake of argument, that we figure it out. We'd then need to stretch this space-time, filling it with energy, which we would then convert into matter. We've now got a space-time filled with matter. But it's not enough to just have these components. They need to be set in motion. They need to interact, to evolve, to give rise to the complexity we see in our own universe. This leads us to another key ingredient: the laws of physics. These rules dictate how matter and energy interact over time. They shape the evolution of our universe, leading to the formation of galaxies, stars, and planets. So we have the ingredients, but how do we set them in motion? Creating a universe will require a monumental event: our own Big Bang. It's a tantalizing thought, isn't it? But how could we, as mere mortals, initiate an event so grand and cataclysmic? Well, the answer may lie in the realm of high-energy particle accelerators. Particle accelerators, like the Large Hadron Collider at CERN, have already given us a glimpse into the origins of the universe. They do this by smashing particles together at almost the speed of light, creating conditions similar to those just after the Big Bang. This provides us with a window into the fundamental nature of matter and the universe itself. So, could we use particle accelerators to induce a Big Bang? In theory, yes. If we could create the right conditions, with enough energy and in the right environment, we could potentially trigger a new Big Bang. But this isn't something to be taken lightly. We're talking about creating a new universe after all. This brings us to some critical ethical and safety considerations. Initiating a Big Bang could have unforeseen and potentially catastrophic consequences. Could we control the event once started? What if the new universe interacted with our own in harmful ways? These are not idle questions, but fundamental issues that need to be addressed before any such experiment could be contemplated. And then there's the question of responsibility. Assuming we could create a new universe, who would be responsible for it? Would it be the scientists who initiated the Big Bang, the institutions that funded them, or the whole of humanity? And what rights, if any, would we have over this new universe? The Big Bang experiment is a concept that could change how we understand the universe. But what would we do with a new universe? These are profound questions, ones that challenge the very limits of our knowledge and ethics. But they're also questions that we may one day have to answer. For now, they serve as a reminder of the awesome power and responsibility that comes with scientific discovery and innovation. A new universe could be a blank canvas, full of potential and possibilities. Imagine a space where the laws of physics could be different, where the elements we know may not exist, and where new forms of matter and energy might arise. The creation of a new universe could offer us a playground for scientific research and exploration. The mysteries of dark matter, dark energy, and the very fabric of space-time could be solved in our own backyard. But beyond the scientific implications, think about the potential for exploration. The universe we inhabit is vast, with billions of galaxies, each containing billions of stars and potentially habitable planets. A new universe could multiply these opportunities for exploration exponentially. We could witness the birth of galaxies, see stars form and die, and perhaps even discover new forms of life. And let's not forget about colonization. Yes, it sounds like the stuff of science fiction. But if we could create and control a universe, why couldn't we populate it? We could engineer worlds perfectly suited for human life, or even create environments to support new life forms we design ourselves. However, with great potential comes great responsibility. The creation of a universe is not something to be taken lightly. There are ethical considerations, potential risks, and unforeseen consequences to consider. Could we inadvertently create a universe hostile to life? Could our actions have unforeseen consequences in our own universe? And who would have the right to control or explore this new universe? These are challenges that we would need to address before embarking on such an ambitious project. But they are not insurmountable. With careful planning, rigorous scientific research, and thoughtful ethical considerations, we could navigate these challenges. We may be far from creating our own universe, but it's a fascinating concept to explore. As we push the boundaries of what's possible, we're not just exploring space, but also the depths of human ingenuity and imagination. The potential of a new universe is a testament to the limitless possibilities of the human mind. Creating our own universe is a concept that pushes the boundaries of our imagination. We've journeyed through the cosmos together, exploring the Big Bang Theory, a concept that still holds mysteries and fascinates us. We've delved into the intricate science of creating a universe, a field teeming with potential and rife with challenges. We've conducted our own Big Bang experiment, an audacious attempt to replicate the birth of a universe in miniature.